Water Flows, a series of informational programs about water. Water Flows will look at a number of issues: water conservation, preservation, purification, and sustainable use. Non-natural waters. Water habitats are dynamic and constantly changing. Over a period of years, a pond may steadily lose its open water as vegetation takes over and eventually disappear altogether. The time this takes varies according to the size and the depth of the pond. Tiny floating organisms, plankton, sink to the bottom where they die along with any silt that has accumulated or dying plants. Gradually, as the pond fills in with this material, reeds invade further into the middle of the pond. It is easier to monitor ecological changes by studying where gravel or clay extraction has occurred. Rainwater soon fills up these ponds, and the animal and plant species that arrive can be seen to change over several years. By damming the head of a valley to collect water from the natural runoff, we create reservoirs which are deep and have more in keeping with a lake. In the early part of the 20th century, many lakes were rich in aquatic life, but by the 1980s and 1990s, things had changed. Sulfur dioxide gases produced by industries burning fossil fuels were released into the atmosphere and dissolved into the clouds to fall many miles from where they were produced. This acid rain greatly increased the acidity of lakes. The release of aluminum from the soil as the acid rain percolated through it drained to the lakes and killed much of the life in the lakes. Acid rain refers to a mixture of wet and dry material from the atmosphere that contains higher than normal amounts of nitric and sulfuric acids from both natural sources, such as volcanoes and decaying vegetation, and man-made sources. Acidic and basic are two extremes that describe chemicals, just like hot and cold are two extremes that describe temperature. Mixing acids and bases can cancel out their extreme effects, much like mixing hot and cold water can even out the water temperature. A substance that is neither acidic nor basic is neutral. The pH scale measures how acidic or basic a substance is. It ranges from 0 to 14. A pH of 7 is neutral. A pH less than 7 is acidic, and a pH greater than 7 is basic. Each whole pH value below 7 is 10 times more acidic than the next higher value. For example, a pH of 4 is 10 times more acidic than a pH of 5 and 100 times or 10 times 10 more acidic than a pH of 6. The same holds true for pH values above 7, each of which is 10 times more alkaline, another way to say basic, than the next lower whole value. For example, a pH of 10 is 10 times more alkaline than a pH of 9. Pure water is neutral with a pH of 7.0. Join us again soon for another program. That's it for today's episode of Water Flows. You've been watching Water Flows. Water Flows looks at a number of issues related to water, including water conservation, purification, and sustainable use. Join us for another program.